Okay, the first problem here today, well, first time for me today. I started these the other day, but problem 6.4.16, describe the graph of g of x equals a half log base 4 of x. That's 1/2 times log base 4. And they want to compare how that would be changed compared to the just plain parent graph log base 4 of x. So the only thing different is the 1/2 in front. And that's just a vertical stretch. If you had wanted on the first one a horizontal, remember how that works on the x itself right here, you would have had to have had like an x plus or minus some number. That would have been your left and right. And remember that's backwards. A minus is right and a plus is to the left. If you'd have wanted the, so that's why there's no shift left and right. There's no shift horizontally. And the next one, for the vertical translation, there's also no shift. Remember how that works is if you had that g of x equals the log base 4 of x, and outside of here there had been a plus or a minus number. Or sometimes some places will write it in the front, a negative or a positive in front, and then a number. Let's see, that's not quite right. Let me rewrite that. A number, and then a positive or negative number, and then plus. And so that would be a minus goes down, and a plus goes up. So that's why there's nothing outside of this being added or subtracted onto it to shift the whole graph up and down. The third one here, a vertical stretch and shrink, and that's what we have here. The 1/2 in front of the log, that is your vertical stretch and compress. If that was a number greater than 1, then it would be a stretch. Since it's a half, it's going to actually shrink it. So multiplying the parent graph from, there is a vertical, let's see, describe the vertical stretch slash shrink, easy for me to say, of the graph of the parent function and select the correct answer below. So it's going to be a shrink because of the half. And so it shrinks at 1/2. Then there's some more to this question. So let's go over here to the next part. Still have that 1/2 log base 4 of x for mine. You probably have something slightly different. Reflections. So if there's a negative in front of the x part, so if you have a negative in front of an x inside of here, then that's going to take your boards kind of get mixed up there. So if I have a negative in front of my x somehow inside of there, that's going to change the x's. So on the graph, x's that would have been here would have been over there. So that would be a reflection over the y-axis. In this case, if you had a negative in front of the log, that's like you're on your y. And so that would make your y's change from negative to positive. So if you think about that, if I had a number up here, I'd move it down there. So that would be reflecting over the x-axis. So we don't have a negative anywhere in this problem. So reflections, there would be none. There's nothing across either axis. And then the next one says compare the asymptotes. So if you have your log graph, you're going to basically be saying the 4 to this power, the base 4, well, hold on, that's not quite right. If let's multiply that 2 to the other side. So if I had that 2 on to the right, I'd have 2y equals my log base 4 of x. So this would be 4 to the 2y equals my x. So y can be anything there, negative or positive, but as my y gets to be a really small decimal, this graph is going to come down here and then go up here. So my y-axis right here going down is going to be a vertical asymptote. So that's why my y-asymptote is the y-axis, which is the same as the asymptote of the parent function. Okay, so compare the asymptote. because this one is just 4 to the y equals x. So y, as it gets to be a smaller and smaller decimal there, or negative, my y goes negative down here, then that's going to be a tinier and tinier x. But then compare the x-axis intercept of the graph. So your x-intercept here, whether you're doing the 4 to the y of x or 4 to the 2y, your x-intercept, if y is 0, so anything 4 to the 0 power would x would be 1. So if y is 0, then 2 times 0, anything to the 0 is 1, and that would be the same thing as if I did that right here. So if I did 4 to the 0, that would be 1 there. So when x is 1, y is 0 there. So when it said compare the x-intercept, that's why the x-intercept of 1 will have the same, the x-intercept is 1, and it's the same for both of them.